Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizman bin Muhammad Razani. First, my part is introduction. A water distribution network is made up to a system of link, sources, pipe, and hydraulic control device that device such as pump, valve, regulator, and tanks work together to supply customer with the right amount of water at the right pressure and quality. The behavior of a water distribution network is determined by the physical laws that explain the flow connection in the pipe and the hydraulic control device, as well as by the needs of the user and the system structure. The behavior, our consultancy firm has been hired by College University Perlis to build a water distribution network. The project's goal is to give tenants in the area water distribution system that operates practical and reasonably priced, and deliver the necessary volume of water pressure that is acceptable. This design was transformed into MWA design guideline for water supply system based on Malaysia JKR standard.
Very good morning to beloved lecturer Dr. Nur Amira and my fellow groupmates. I'm Punita Ganesan. My metric number is 2111311817. Today I'm going to present the chapter 2 of this project, which is development plan. In this project, my groupmates and I designed an effective water distribution network system in Perlis Matriculation College that focused on current and upcoming 10 years of development and population increment. Therefore, this development plan is fully focused on water demand at Perlis Matriculation College using water demand estimation. Water demand analysis is the method used to estimate the quantity and trends of water utilization within a specific area or system. Moreover, the calculated current and future water demands depends on water consumption, which include of population, economic activity, climate, and water management practices. In this project, the Perlis Matriculation College separate into 5 loops to estimate the water demand. Uniform Technical Guidelines of Suruhanjaya Perkhidmatan Air Negara is referred to obtain average daily water demand to calculate water demand rate of Perlis Matriculation College. In first loop, there are guardhouse, sport complex, and courts. The total water demand for this loop is 0.742 liter per second. Then, in the second loop, there are hostel block A1, A2, A3, B1, B2, B3, and cafeteria. The total water demand for this loop is 5.694 liter per second. In third loop, there are hostel block B3, C1, C2, C3, and cafeteria. The total water demand for this loop is 4.028 liter per second. Moreover, there are science labs, staff quarters, classrooms, and study rooms in loop 4. The total water demand is 3.716 liter per second. In loop 5, there are lecture halls, administration building, language and computer lab, Al-Falah Mosque, gym, restrooms, mini-marts, Najatul Hilham Library, Sri Kajang Main Hall. The total water demand is 2.771 liter per second. Finally, the total water consumption in Perlis Matriculation College is 16.951 liter per second. The total per capita demand is 488.217 liter per capita per day for 3,000 pupils in 10 years, including bomber hose demand. That's all from me. Thank you.
Based on this study, given that Sungai Perlis is the water sources, the storage reservoir is the most truthfully verified type of reservoir according to the site condition assessment. The Area Water Treatment Plant is located next to the Sungai Perlis River, which has a daily raw water storage capacity of almost 50 million cubic meters. In addition to meeting demand in the future and ensuring supply is sufficient during the dry season, the reservoir can phase out outdated WTP with erratic raw water sources. Water appropriation has halted by this kind of reservoir. Subsequent investigation revealed that this reservoir might offer enough water to meet the needs of every College Matriculasi Perlis resident. As for the distribution reservoir or survive reservoir, the type reservoir selected is an elevated reservoir. Due to the existing geographically condition of Arau, the water source, which is Sungai Perlis, is located at the highest elevation point, which is 88 meter above sea level compared to elevation of the whole distribution area. For College Matriculasi Perlis is flat with low-lying area. Consequently, a total height of 50 meters is intended for the supply receiver in order to sustain the gravity flow. The service reservoir is located at a height of 50 meters with an minimum water level of 10 meters and a maximum of initial level of 50 meters. And for the reservoir is 30 meters in diameter. A steel pipe is chosen to serve as the water distribution system pipeline for the College Matriculasi Arau. After all the factors are taken into the problem. When it comes to water distribution in different types of water supply system, steel pipes are the material of choice because of its many benefits. For propose the steel pipe from the reservoir to the tank with the pipe diameter selected 200 mm and 150 mm from the tank distribution and through the matriculasi. Steel pipes are relatively expensive, but their strength and durability still will bend instead of breaking in harsh circumstances. Preventing spills or leak as well as the superior hydraulic condition allow them to withstand high water pressure and prove their usefulness in a distribution system. Steel pipes are also simple to install since they can be made to match the precise measurement needed for the distribution system in terms of height, width and strength. Which are simple to install and can be readily altered on site after installation. Any required upkeep or adjustment can be complete fast and simply. For the size and diameter of pipe are selected through the reference of specification of steel pipes, fitting and joints for water and sewage from Suruhanjaya Perkhidmatan Air Negara span. Any possibility of leakage can be decreased through the increasement of pipe diameter, as the high diameter result in low head loss in the College Matriculasi Perlis area.
IPANET is a free and open source software program used to model and analyze water distribution system. It's widely used by engineers and consultants for a variety of purposes. The purpose is the designing and sizing new water infrastructure, simulate the flow of water through a proposed water distribution system, helping engineers to determine the appropriate pipe size, pump capacity, and tank location. This can save time and money by ensuring that the system is designed to meet a community without overspending. Next is investigating water quality problem. Simulate the transport of contaminant through a water distribution system. This information can be used to identify the source of contamination and develop plan for addressing the problem. And then the optimizing operation of tank and pump develop strategy of optimize the operation of this component, thereby reducing energy consumption and improve water quality. There is component in IPANET software we should know. That is run analysis, graph, table, zoom in, zoom out, junction, reservoir, tank, pipe, pump, valve, and text. This is a result video. We built a water distribution network in Matriculation Perlis using IPANET software, and this is the result. Result water is flowed to each loop or demand, and the storage tank can store emergency water. Water flow run 24 hours without stop when the tap is switched off. This is graph pressure versus time. This occurs because of the highest pressure during the late hours, when water consumption is minimal and most taps are switched off. During the morning, when individuals waken and engage in their daily routines, and in the hot afternoon, when many people use the water for personal cooling or during daily routine, and many more. The water supply experiences a decrease in pressure. In simple terms, pressure will be raised in the absence of water use and reduced when water is utilized. Graph demand versus time. This link refers to the pipeline representative for each proposed loop in the matriculation Perlis network pipeline system. The reading is different every hours. This is because of the low water demand at 000 to 0300. At the time, the water demand is low because of the tap are closed. After that, we start increase from 0400 to 0800. This is because users start turning on the water tap, get up from the sleep, and prepare to their daily activity. In short, according to the graph above, the reading will increase if there is a lot of consumption at the same expected time, and the reading will decrease when the user use less water at the same expected time in the Perlis matriculation area.
Lastly, summary and conclusion. Okay, a software program called IPANET is used to research water distribution network all over the world. Okay, for this project, College Matriculasi Perlis audits water infrastructure will be replaced with new infrastructure that designed and sized using IPANET. Okay, a reservoir is a node in the network. The represent an endless external water source outflow. The height or elevation at 70 meters above sea level is the main parameter for this source. Is animal size relative to the system mean that the volume is constant regardless or the amount water intake or output. Okay. The project have a concrete. Okay. The project is two diameter. First, 150 millimeter, and the 200 millimeter are distinct from one another because they regulate the water pressure in each loop, which has a separate water requirement. Okay, and the pipe have a concrete liner, smooth steel construction, and a Hazen-Williams coefficient of 100. The pipe is a great option for this project because it is affordable, long-lasting, resistant to corrosion, and easily flexible. And the current water distribution system does not need to be changed in order for the suggest design to continue meeting water demand for the next 10 years. Okay, concrete pipe is the best material option since it can withstand variation in pressure and weight. When the system operating continuously, the IPANET simulation demonstrated the design is highly stable. Okay, thank you.